Okay. Yeah, hopefully school doesn't get canceled, but here we go. That's on video. So we're doing 4.3, composition of functions. So we did combinations. So combinations, that's where we're adding, subtracting, right? So that's where we're going like f of x plus g of x, etc. We'll have all the operations, okay? That's combinations. Composite functions is when you take one function, then put it inside another one. So here it is. To look at composite functions, we look at the idea of placing one function inside another function. The inside function is evaluated first. Okay, and then the resulting value is placed inside the second function, and then that's evaluated. So just remember to work inside out, and you will be okay. Give you a smiley face. All right. So let's take a look at a quick example. You can kind of, or an analogy rather, you can think of this as like a machine that spits out a number. Okay, so you got your two functions, machine A, machine B. You're putting in an input into this function. You get an answer that you then put into this function, and then you have your output. Okay, so that's kind of like how composition works. So let's quickly try. What do we got? 3 examples. Let's just do like one of them. So say x is 3. So step 1 is we're going to put it in there, and we're going to go, okay, from machine, I'm just going to put machine A. What do we get? We get 2 times 3 plus 3. So what do we get? 9. Beautiful. Now you're going to take that 9 and you're going to put it in the second machine. So I'm going to go machine B. So we go 1 over 9 plus 5. And then you get your output, your final output of 1 over 14. And that would be composition of functions. I don't think we need to do all of them. I can give you answers if you want to try. Try this one on your own. I'll give you 1 moment. Plugging in 0. Shouldn't take too long. What do we get from machine A?
1 over 8.
3. And then when you get B? 1 over 8. Perfect. Okay, let's leave it at that. If you are looking to try it at home, this should give you a quarter. That's for x equal -2. Let's look at it with some actual algebraic functions here. So let's say we got f of x, and it's 2x minus 4, and g of x, a little bit more complicated, x minus 1 squared. This is how you write the composition. So you would read this f of g of x. So that means you're going to take g of x, this one, and wherever there's an x, you're going to pop in x minus 1 squared. So here it is, f of g of x. So 2g of x minus 4, plug in g of x, and then that would be your composite function. You can expand it all out, all right? So we can go 2, x minus 1, subtract 4, expand it all out, like FOIL that out. What would we get here? We're going to get, I'm just going to distribute the 2 into the brackets and then distribute it out. So I just distributed that 2 into the first set of brackets, and now I'm going to like FOIL this out. I would get 2x squared, and then I get a negative 2x, another negative 2x, so I have negative 4x, and then subtract, or no, negative 2 times negative 1 is plus 2, subtract 4 is negative 2. So this would equal f of g of x. So now you have an algebraic function for f of g of x. And if I started asking you to pop in something into g of x, you could plug it in and get the whole answer. Yeah, it can work in the reverse direction too, right? So we can take f of x and plug it into g. And here it is down here. So if you were to go to g, so g has x minus 1. So wherever there's an x, you're going to plug in 2x minus 4. So inside the brackets, you get 2x minus 4, right? This used to be x minus 1, right? And then you could, evaluate that. So what would we get? We get 2x, negative 4, subtract 1. So we get 2x minus 5 squared. And you can FOIL that out, and you would get, let's see, 4x squared, and then you would get a negative 20x plus 25. Good? So that's how you do it algebraically. Sometimes they might give you like a mapping. So this, by the way, is just the official definition of composition of functions. So given f and g are two functions of x, the composition of f and g is written like this, f of g of x, or, oh my goodness, you guys see this one? That's an open circle. So this and this are the same thing. And be careful, because on the exam, they'll use this one, because one of their favorite tricks to do is, you know how we can go f of x times g of x? Right, so what's the difference between this? So difference between that, or think about this. So be careful, because they don't always do it, but it comes up every now and again. They'll have this, they'll have this. There was a theory question one time where they were like, what's the difference? They'll be like explain what the difference is. Right, so here this means you're taking f of x and you're multiplying by g of x. This one means that you're doing this, which means you're taking g of x and substituting it in for every x and f of x and then simplifying it, right? So just remember, this is the one that goes inside for that notation. It's just another notation. Okay, both expressions read as f of g at x. Okay? All right, so we went through that. This is if they give you a mapping. So sometimes they'll give you discrete points, or they'll give you a mapping, and they'll ask you to like find certain things. So let's take a look at what we got down here. So just note that this is x going to g of x and x going to f of x. Now, if we were going to find g of negative 1 of f, first, where do we start? Outside in or inside out? Inside out. So first evaluate this. So when x is, so this is x, when x is negative 1, we get 2. So that would be the same thing as f of 2, which we then need to go, so this is x. Here we go. We get 3. So overall, you get the answer 3. Now a backwards question. So they're saying, hey, imagine you go g of x into f and you get 4. So if we're doing this, where are we starting? Is this an x value or a y value? It's a y value, and it would have came from where? G of x or f of x? F of x. So that means start here, go backwards. So the x value would have been 1. And remember, this would have been a y value before. So, so this would be 0. Right? So basically the question would have been f of g of 0, and that equals 4. We can check. So if we start with x equals 0, we get 1, and then we would have plugged that into f, and then 1 would have given us 4. Wow. That blows my mind. Okay, what have we got here? All right, so there is no page 293. This was an old workbook. So basically what this question is doing it graphically. So you can do it graphically as well. So if you want to write that title graphically. So we got y equal f of x, and y equal g of x, and y equal x. And they want us to determine g of negative 1 of f. Right, so first step, go find the y value for g of negative 1. It's just like when we were doing it with the mapping, right? Except this time we have a graph. So let's see, we're going to go to g, which is this one here. I'll highlight it in red. So that's g of x. So we're going to go to x. Someone's clicking their pen. Go to negative 1. And what do you see for a y value? They have it labeled there too.
Negative 1 or 2.
Yeah, so which one do we take?
Huh?
Are we interested in the negative 1 or the 2?
I don't know.
So it's the y value, right? Like go find g of negative 1. So that equals 2. Okay? Now that becomes the value for f of x. So we're going to go find f of 2. And that is this line here. I guess I could use a different color. A little bit thicker. So go to x equal 2. There it is. We have it labeled for us to make it easy. And you look at the y value. So the y value is 3. Okay, so f of g of -1 equals 3. Neat. Let's do another one. Let's do this one here. So start with the inside first. So we're going to go to the x value 4 on f of x. So 1, 2, 3, 4. And we have the point 2 for y, because I guess the scale is going up by 2. So then we would find g of 2. That's the red line. Okay, so go to x equal 2. Go up to g. Looks like we're there. What do you guys see? I think, did we make, what's the scale going? I can't see. Is it going up by 1? 1, 2, 3, 4. Oh, it is. So this is wrong. I was looking in the wrong place. Right? Is it clear on your page? Like, I think it's 1, 2, 3, 4, 5, 6. Yeah? Okay, so we made a mistake. We looked up f of 4, and that is the line. So we went to 1, 2, 3, 4. Yes. I saw this 2, 2, but actually I'm looking over and I get the point 1 for y. Do you guys agree? Yeah. Okay, so we should be looking for g of 1. And now we go over to x equal 1, and that would be y equal 2. So you get the answer 2. So overall, this thing equals 2. Pretty easy? Right, like you get the x value, you go look up the y value, that's the next x value in the next function, and then you're off on your merry way. And yeah, we can do a table of values. So there's two functions. This is very similar to the mapping. It's basically the same thing, but let's just do some more practice. So let's go find the answer to this. So this is the x value in g, right? So remember, that's the x value. We're going to go to -1, and we see that we get 2. So now we're going to find f of 2. So go over to f of x, go over to that table, go to x equal 2, and you see 0. So overall, you get the answer 0. So I'm just going to restate it. There. So when you're writing your answer on the exam, make sure that you write it like this. Okay? Don't have like a big long chain of like equals, equals, equals. If you have more than one equal sign on a line, you'll lose half a mark. So just make sure that you're stating your final answer. Okay. Let's see. Oh, can we plug a function into itself? Yeah, why not, right? So we're going to go to f of 1. So go to x equal 1 and you get -1. So you can do it like this. Like you can write equals, so f of 1 is -1. Okay, so I'm just saying on the exam, then you can write f of -1 equals, because we're going to go back to f again. And do we have a -1? Yes, we get 3. That would be fine for work on the exam. Like, or you could just do your work somewhere and then just write f of 1 equals 3. That would also be acceptable. Okay? All right. Another question with some graphs. So given the graphs of f of x and g of x, determine some values below. Maybe take a moment and see if you can try the first one on your own. I'll give you like just like 4 or 5 seconds to get started. Gotta drink some coffee. Okay, so we're looking for g of -2. That means when x is 2, now this is f of x, the linear function is g, so we go up till we get to the y value, and we go over and look. Now it looks like every square is worth 1, so this would be the value 8. So you would say, okay, well this is equal to f of 8. On the x-axis, go find 8, go up to f. What do you guys see for a value there? Oh, I forgot, nobody's in the room, right? So just teach you. Is it 3?
3.
Ah, yes. I just edited in that voice after. There's actually nobody
Okay.
here. Yeah. I'm just some crazy person in a classroom just teaching you. Okay, f of 3 for b. So we're gonna go to f. That's this. What kind of graph is that, by the way? Yeah, it's a square root graph radical. Excellent. You go up to find x equal 3. What do you see for y? 2. So this is g of 2. And then you can go find g of 2. So go find x equal 2. Oh, there we are. There's g of x. So we get the value. What is it? 0. If you want to try it yourselves, I will just give you the answer so you can try it later, but you will get 1 and you will get 4. We can go try it out later. Okay. Now let's do some of this algebraically. So that's the third example. The third example is doing it algebraically. Ooh, what's that called again?
Flip the y over.
No. Absolute value. Yeah, that's absolute value. So this is the place where they do like to play with absolute values occasionally on the exam. They're not asking us to find, so they're not saying, hey, go algebraically find what f of g of x is. They're just saying, here's your two functions. You don't have the graphs this time. Go find this. Okay, so nothing really changes. Well, I guess it's completely different, but you're going to go plug it into the actual function. So go find g of 2. So which one's g? This is g. So plug in 2 to get 1 over, I don't know if I can write this. There's not a lot of room. You can get 1 over 2 squared plus 1. What does that give us? 1 over 5. So I just wrote g of 2 equals this. That's 4 plus 1, so we get 1 over 5. Then I need to go find f of 1 over 5. So I'm going to go into here, I'm going to go absolute value of 1 over 5 subtract 1. Now let's think. What's 1 as something over 5? Like common denominator, right? Back to grade 6. 5 over 5. So 1 over 5 subtract 5 over 5 is negative 4 over 5. You do the absolute value?
4 over 5.
Exactly. You get positive 4 over 5. So that's what that equals. Alright? Yeah, I hope you can write smaller than me or go to the bottom of the page, but I'm sort of stuck writing there. Let's do this one. So now I'm going to f of 2, so I'm just going to do my work over here. So f is the absolute value function, so it's going to be absolute value of 2 minus 1. I try to make my absolute values really big so they don't look like 1s, okay? So let's see, what do I get here? I get 2 minus 1, which is 1. Absolute value of 1 is 1. Now I need to plug that into g, so I'm going to go g of 1, and here's g. So my work would look like this. It's going to be 1 squared plus 1. Overall, you get 1 over 2. And that's your answer. Please realize that this is not the way, you could do your work like this on the exam. If you leave your answer like this, you'll lose half a mark. You should you can have your work, and then at the end of it, if you want to write it like this, this would be the best thing to do. Right? So it's here's my answer, there's my work kind of thing. All right, let's do C. So we're plugging f of x into itself. So we're going f of negative 3, and that's the absolute value, like this. What is it? Minus 1, right? So negative 3 subtract 1. Now that gives us negative 4, correct? But then when you do the absolute value, what do you get? Positive 4. And then we're going to take this and we're going to plug it into f again. So now we're going to go f of positive 4. So that's going to be 4 minus 1. You get 3. Absolute value of 3 is still 3. So then you should write f of negative 3 equals 3. Should we do the last one? Let's not. It gets really ugly with all the fractions, and they generally don't do stuff like that. I can give you an answer, though. I did it.
Where I didn't really clearly state what my answer was. Did I finish it? Oh, okay, let me see here. When you go g of negative 2, you get 1 over 5, right? Yeah.
So 1 over 26 over 25?
And then you have 1 over... I don't think did I actually finish it? I don't know. Let's just skip it. I will give you answers for, there's some try it yourself, is on the next page. Yeah, there's some try it yourself. So if you're looking for answers, I got 238. Looks like an 8. I'm pretty sure it's a 238. And then for this one, I got negative 250. So you can try them out on your own time. If you have questions, come see me, right? Oh, what do we got next? Oh, these, every once in a while, yeah, you get one of these. Now, these are no fun. We're not going to necessarily do all of them, but let's see. So they say, given f of x is x squared plus 3x and g of x is 3x minus 5, determine an explicit equation for each composite function. Then state its domain and range. Again, on the exam, they usually stay away from range, so I'll let you know question by question if it's going to be appropriate, because they get pretty tricky for range sometimes. This is from an older workbook where math used to be so much harder. Okay, so let's see. We're plugging g of x into f of x. So you're going to take this, and wherever there's an x, and use brackets when you have a squared or anything, we're going to plug in 3x minus 5. So this is going to look like this. We're going to take 3x minus 5 squared, right? So this is like x squared from before plus 3 times x. So 3 times 3x minus 5. And then you got to simplify it. So that's a good first step. These are usually like 2-mark questions. So sometimes they give half a mark for doing that or something like that. Then you got to FOIL it all out. So I hope you're getting better at FOILing and you can sort of do it a little bit in your head. So you can go 9x squared, and then you're going to go 3 times negative 5, so you get negative 15x. Then you go negative 5 times 3x, you get negative 15x again. So in total you got negative 30x, and then negative 5 squared is 25. Right? All I did was this. And I FOILed it out, right? 3x times 3x, 9x squared, and then you get a negative 15x, and you go this times this, and then this times this gives you another one, and that times that, okay? Start trying to do it quickly. Have I forgotten anything?
Oh, yes.
Yeah. Gotta finish up this piece too, right? Okay. Yeah. There we go. So 3 times 3x, that gives me 9x. And then 3 times negative 5 gives me negative 15. Good, do I gotta group my like terms? You betcha, we're almost there. So there's only one squared term, so I'm gonna write 9x squared. But then I got a negative 30x and a 9x, which gives me negative 21x. And then 25 subtract 15 gives me 10. And now you have your explicit equation. I remember the whole, like, when we were doing combinations of functions, that, like, you take on the most restricted domain. I did negative 30x plus 9. That gave me the negative 21x.
Oh, sorry.
Good? Yeah.
I'm good.
Everybody's good? Good, that's a good question. Definitely stop me if you're confused. What were we doing? Domain and range. So, typically, your domain is going to be, like, you're going to want to look at your new function, and you want to consider if there was any restrictions from before. So does this have any domain restrictions?
No.
Nope. It's a line, right? Plug anything in there. Does that have any domain restrictions? Nope. Like, you can plug in any x value, right? So, like, you're not going to get a division by 0 or anything weird. There's no square roots. Okay, so the domain of this one, now look at this. What kind of graph is that? It's a parabola. Do parabolas have any domain restrictions? No. So your domain is still x element of the reals. Now your range is a little bit trickier to find because you got to go find the vertex.
So they don't generally do that all at once on the exam. So on the exam, they'd be like, what's the explicit equation? Okay? Or they might be like, here's the two original functions, here's the explicit equation, what's the domain? Okay, they might do something like that. So we won't worry about the range. I would just say, find vertex. And I'm not here to teach you grade 11 pre-calc, but I know a YouTube channel that has all that stuff. Right? So we'll leave that alone. Let's see. Right, we can also check and see. This isn't foolproof, like sometimes you get unlucky, but once you have your explicit equation, one thing to check would be, hey, if I plug a number into here, into this one, do I get the same answer as plugging that number into here, taking that answer and plugging it into there? Right? Should we do that? I don't think we need to. I'm just going to warn you that that's something that you can definitely do. Let's do another. Do you want to do another one? Let's do this one. So same two equations. This time we're taking f of x, substituting it into g of x. So here we go. I'm going to take f of x, and wherever there is an x in g of x, I'm going to write x squared plus 3x. So let's see what we get. It's going to go over here. It's going to go g of f of x equals, so f of x goes into there, we go 3x squared plus 3x minus 5. Okay, that looks good. Now just clean it up, so you get 3x squared plus 9x minus 5. And then there's nothing left to do. Huh? Domain and range? Yeah, let's take a look at domain and range. Well, we know there's no restrictions. So the new one shouldn't have any restrictions, but just check. Still a parabola. So the domain is still x element of the reals. And the range is still, we'll go find the vertex. Right? And then that would be y greater than or equal to whatever value. We're not going to do that. That's not why we're here today. Let's skip this one. I think we get it, right? You can plug f of x into itself. Let's just do it. Actually, no, let's not. I'll give you an answer though. You can turn it into a try it yourself. I'll give you the answer that you'll get if you were to do it. Because I did it. So if you want to try another one, there it is. So x to the 4 plus 6x to the 3 plus 12x squared plus 9x. Alright. Guys, I think that's basically it. There's another one of these, but we don't need to worry about it. If you want answers for that, I have them. Do you guys want some answers? So for 8, you get this. I mean, this is overkill. We've done enough examples, and then you're going to go do the ones in the homework, but that's what you would get. For B, I got 4x squared plus 9. And then for C, I got 4x plus 21. Very, very, very similar. Okay, last little caution. So we already talked about this, but don't confuse this with multiplication, okay? Yeah, so this is actually the one I was thinking about. So it was on the exam one time. They had what's the difference between g of f of x versus f times, so a closed circle, right? So this means take f of x multiplied by g of x. This means take g of x and substitute it into f of x, right? So remember, the other way of writing this, if I wasn't clear before, is like this. I prefer this notation to that one. So, okay. So you guys are doing 4.3. I'll check and see if we got a supplementary handout with anything useful on it. Maybe I'll crack open an exam right now and we'll take a look. But I'm not going to do that on video. So, see you next time. How do I turn it off?